the spell work question, I asked you to tell me what something meant when we are talking about like terms. So I'm actually looking for 3 things that something could be like terms. So does anybody know one or multiple of those things that would make something a like term? Asa, what's one of them?
The variables.
Variables are the same, exactly. So variables are the same. What else would make something like? Anybody digital? Selena said they have the same exponent. Agreed. So that's 2 things. What would be the third thing? Bryce, do you know the third thing, or did you know one of those things? You know one of those things. What would be the third thing, Madison?
The same sign.
Not necessarily, because like -2 and +2 are still like terms, even though one of them's negative and one of them's positive. Yeah, Robert.
Having both a variable and exponent.
They could, but what if they don't have a variable or an exponent?
Is there a whole number or not?
There's a better word.
Oh,
Trey?
by being like the same, like order, like you know how there's rational and all that, and irrational.
So you can still be like terms with things that are different categories, but what is something called that doesn't have a variable, doesn't have an exponent?
Oh.
Ooh, don't let me down. Yeah, Bryce.
A natural number.
No. Starts with a C. Yeah.
Constant.
Yeah, constant. There we go. Ding, 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 constant. So you either have to have the same variable and exponent, or you have to be a constant. What we're going to do is we're going to be using a lot of different colors today. So if you are not comfortable in your notebook with the draw feature, then I would suggest using a sheet of paper, at least for the first couple problems with different colors. But if you are comfortable with the draw feature and like changing the colors of your pen or pencil, then that's good too. Whatever is easier for you is easy for me. So go ahead and go to your notebook, and we're going to be looking in lesson number 7 that says combining like terms. And make sure if you get in there before me, go to the draw feature, make sure you're able to like change the colors. You'll need 4 different colors at some point. So make sure that you have access to 4 different color drawing, or you can change the font color or whatever works for you. Okay, so we just talked about the 3 things that make something like terms. The first thing was same variables. And I'm going to put variables plural because it could have more than one variable. Same power or exponent, those words are synonyms. I'm going to use the word exponent. And then if they don't have those 2 things, then we call those constants. So I'll give you a moment to do that. So same variables and exponents, or they have to be constant. You do not have to do this for any of the problems after this first one if you do not want to, but I will want you to do this process for the first one we do together, and then the rest of them, I don't care, okay? The first one, we are going to underline all the things that are like. So we're going to start with -2x. Does anybody see a like term with -2x? Amelia, what do you think is a like term with -2x? Okay, and I'm going to be specific. What's in front of the 4x? Negative. Good. Nihal, I saw your hand up. Do you see anything else that is like with the -2x and -4x? Oh, he was going to say -4x. There's one more thing. Selena, you can answer if you'd like to. Negative 15x, I agree. Beautiful. So we're going to write these as a little group together. So we have negative 2x, negative 4x, and negative 15x. And I'm going to circle them because I know that that little group is like terms. Okay, so let's do our next group. So I'm going to change colors. I'm going to use teal. You can use whatever your next color is. I'm going to go to my next thing, which looks like a constant of 3. What would be another constant? Luke, what's another constant? 5, agreed. So we have 3, we have 5. Didon, do you see another constant? We'll wait for him. You got this. No pressure. Yes, 11, good. 11. Last one, Asa?
15.
15, be specific.
Negative 15.
Yeah, negative 15. We want to make sure we include the sign in front of it. Awesome. So those are one group, my constant group. Now, why didn't my x squareds go with my x's? Henry, why not?
The exponent is, what is it called? Is not a part of the variable. Well,
Okay, can you explain yourself a little bit more?
like,
So what were the rules for it to be a like term?
they had to be either same variable, same constant, or same exponent.
Okay, and same variable and exponent go together. So yes, it has an x, but the exponent on the x's is not the same as the exponent on the x squareds. Yeah, so that's why we can't put them together. So we need to make a third group, which is my x squareds, which would be my negative 4x and my positive squared, excuse me, and my positive 2x squared. So we have minus 4x squared and 2x squared as my last little group together. Yes, sir.
If it was like negative 4 squared, would it not go with the 2x squared?
If it were negative 4 squared, I would encourage you to simplify that first. And then that would just be a constant, right? Because it would be 16. Okay, good question. So let's actually simplify. I want you to not even think about the variables right now. If we look at this first group, let's just pay attention to the coefficients. Negative 2, negative 4, negative 15. If I put those together, AKA add those together, what number would we end up with? If I put those three things together, what would I end up with? What do you think, Amelia? Negative 21, but we do have to include the variable now, which was x. So that would be negative 21x. Awesome. Good job, Nihal. Okay. Constant group. 3 plus 5 would be 8. 8 plus 11 would be 19. 19 minus 15 would be 4. So we have a positive or plus 4. And then my x squared group again, let's just pay attention right now to the coefficients. Negative 4 plus 2 would be minus or negative 2. And we got to include x squared as our variable and exponent. And that's literally all we can do. We can't do anything else as far as combining. Unless I told you like what x equals, which I haven't yet. I'll give everybody a moment to catch up and we'll try the next one. my beautiful circle colorful method, you don't have to. It'll make me a little sad, but that's okay. If you just want to do it in your head, cool with me. Won't be as pretty, but whatever. Okay, so let's go on to our next group. So let's start with X. Lauren, do you see another like term with X in the second problem? You can unmute yourself if you want, or you can type it, whatever's easier for you. Okay, great point. So Lauren said XY. So I want everybody to look at XY. Does anybody have anything to say about that? Bryce, what do you think?
The X has Y as a variable.
It does. But X is also a variable, right?
Yes, but
Mm-hmm.
it has to be X by itself.
Yes, okay, so it has to be X by itself. So we're actually gonna put XY in its own little category in a second. So right now, we just wanna focus on things that have just an X, only an X. Amalia, do you wanna name something else that just has an X? 2X, I agree, beautiful. What else? Go ahead, Luke. -3X, is that it? Yeah, I think that's it. So we have X, we have 2X, and we have -3X as our first little group there. So let's go on to our second group, which is our constant. So I have -9. What's another constant here? Addison, you see another constant? -2, beautiful. Cody, you see another constant? -4, awesome. So we have -9, -2, and -4, and I think that that's it for our constant group. And our third group is going back to that XY. So we want to find other things that have XYs. I see a 2XY, but I want to have a conversation about 3YX. Are we allowed to call that a like? You seem pretty confident.
Because it doesn't matter about the order.
You're right. And what property tells us that? Commutative property. So we are allowed to include that -3YX because commutative property says that I could actually rewrite this as -3XY because we're just multiplying those things together and we're allowed to switch the order. So in our red category or XY category, we have XY, -3XY, and 2XY, which is all going to be together. And just for a visual, remember these X's and this XY, we could actually put a 1 in front of there because that coefficient is technically a 1. That might help when we're adding them together for you. So 1X plus 2X minus 3X. It's a great question. Is it an X or is it 0? Yeah.
X.
Why do you say X?
Because the variable, it still stays there, even though.
Does it?
Even though there's a 0.
Does
still
it?
stays.
Does it? Yeah. You sure? Okay. So let's call them things. X is going to stand for xylophones because that's literally the only thing I can think that starts with the letter X? Can anybody think of anything, any other object that starts with an X? Oh, there we go. X-ray. Can I use xylophone? Is that okay? Yes, xylophone starts with an X in case you didn't know. So it does not start with a Z. So that says I have a xylophone. Then I have 2 more xylophones. And then I take away 3 xylophones. So I'm left with nothing. No xylophones. No X, no nothing. 0. 0 xylophones. It's okay. It happens. I'm going to skip the constants for a second. What about my XYs? I have 1 XY, so I don't know what I could use to describe an XY, but 1 XY plus 2 XYs, then I take away 3 XYs, and I'm left with 0. Bye. So all that I'm worried about or care about are those constants. So -9 minus 2 minus 4 would leave me with just -15. So all that work for just a little measly -15. All right, I want you to try the third one on your own. Like I said, you do not have to do my beautiful circles if you don't want to. But I feel like it helps some people to actually group them together before they add and subtract. So go ahead and try that third one. All right, so let's talk about the groups for this problem. So my first group is going to be my X group. So I found that 4X, 2X, and minus X all went in that group. So we have 4X, 2X, minus X. So I'll go ahead and circle those. My second group is going to be my YZ group. So I have 1 YZ here. I have 2 ZY, which is included. We talked about that on the previous problem. What about 4 XYZ? I agree, no, because it has 3 variables, so we can't include it with the other ones. So we're just going to include YZ and 2 YZ as a group. Then I have my constants. My constants here were -3 plus 8 minus 9. And then I actually had one last group, and my last group was just the 4XYZ by itself. It was its own group. And then you just wanted to make sure you combined all your terms together. So 4X, 2X minus an X would leave us with just 5X. 1YZ plus 2YZ would be 3YZ. The next one was -3 plus 8, which is 5. 5 minus 9 would be -4. And then at the end, you would have 4XYZ. Now, I had someone in last class ask, what if I had it in a different order? That is totally fine. Like if you had 4XYZ at the front and then like 5X at the back, you do not have to have the same exact order as I do. What you do have to have are the correct coefficients. So a 5 in front of your X, a 3 in front of your YZ, a -4 as your constant, and a +4 in front of the XYZ. Yes?
Okay, so for the 3YZ,
Mm-hmm.
does it like say that it still count if I put 3ZY?
It does still count if you did 3ZY. Very, very good question. Yes. Same with like 4XYZ. If for some reason you did 4ZYX, like it would still be the same thing. Okay, good question. Okay, let's look at the last question. It would very much help us if we knew what that word meant. Find the perimeter. So what does it mean if we're talking about perimeter? Tatum, do you know what perimeter is talking about? And you can unmute yourself or type it, whatever's easier for you, sweetie. You got this. Oh, hold on. I can fix that. Hold on, I have that. Now try. Y'all should have told me.
It's the outside of a shape.
Yeah, the outside. So the measurement around the whole outside of the shape. So we're talking about these three pieces in a triangle, obviously, because we have three sides. So let's add those together. So 2x plus 3 plus my second side was x plus 1 plus that last third side, which was 3x. So we want to combine all of our like terms. So I'm going to start with my x group. So 2x, x, and 3x are all together. And then my second group would be 3 and 1. And once you combine those, 2x, 1x, and 3x would give us 6x. And then 3 and 1 would give us 4. So our final answer there would be 6x plus 4. Again, can't do anything else unless I were to tell you what x is equal to, which at some point I will. But right now we're just going to leave it as that expression.